second video on the topic of using functions in the C programming language, and we are going to go away from the math functions and the rounding functions. We are going to talk about generating random numbers. So generation of random numbers in the C programming language is something handled by a function from stdlib.h. So anytime you want to use the function related to generating random numbers, or I should say pseudo-random numbers, you are going to have to make sure that you include stdlib.h. Unlike the math function, we don't have to worry about linking anything since the standard library is already linked to our executable by default. So we don't have to worry about a gcc-lm for linking to the math library or else something for linking to the stdlib library. It's already done for us, okay? So what do we have? We have a rand function. There we go. That's it. End of video. All right. So now that we have the basis out there, let's try to do a printf%d of what this rand function returns to us. So no parameter, very easy to call, right? Like the manual is very, very straightforward for this. Not man. I've listened to myself too much manual. I'm thinking about the command man. We're going to talk about the command man in a minute. But for now, GCC, we are going to do main.c. There we go. And then a.out. See, I didn't have to add any -l option. It worked out of the box. And this is what I get. I get a random number, which is between 0 and something called rand max. So if I want to know what is the maximum random number I can get here, I can display %d, and there is a constant called rand_max, also coming from stdlib.h, that's going to tell me exactly what is the maximum random number that I can get with this command is. There we go, and then here's a random number, and maybe I'm going to call it again, and again, and again, just to generate several random number. Let's compile this. Let's run it. So I should have been smarter. If I could, I would. I should have put here \n to separate these guys. There we go. That's going to be a lot better. And same thing here. There we go. Let's try again. So gcc main.c, a.out. So rand max is over 2 billion. Okay, and this is actually the value that's given to you in the textbook for, I think this is the same value on macOS and Linux. It's a different values on the Windows system that they tried it on. And then here are my random numbers. So they are indeed between 0 and 2 billion something, right? But this is not exactly what I'm looking for. Most of the time when I want to generate a random number, I have a range in mind, right? So I'm glad that rand is going to return a number between 0 and rand max, okay? But I need to actually adapt this to a personalized range. For example, if I tell you I want to generate the numbers between 1 and 20, I want to simulate a good old D20, right? How am I going to do this? So there is a technique called shifting and scaling that's going to allow us to do this. So here's how it works. The first component of it is shifting. So by default, we start at 0. If I want to start at 1, it's easy. I add 1 to the value returned by rand. Okay, there we go. If I wanted to start at 20, 23, or 27, whatever is my first random number I want to generate, I can add it here, and it's going to be included in the range. And then how do I make it so that we don't generate 2 billion possible values, okay? Well, I'm going to use a modulo operator, so it's coming handy already. Modulo, let's say that I want to generate 20 different values, okay? I'm going to do modulo 20. So run modulo 20 is going to always give me a number between 0 and 19, okay? This is because of the property of the modulo operator. If I add 1 to that, then that's it. I'm in between 1 and 20. So this is how you adjust your range, right? With the modulo operator, modulo a number that represents how many different possible values you want to obtain, and then you add something in front of that that's going to make your range of random values start at, for example, in this case, 1. Okay. So, all right, let's add a modulo 20 everywhere. And since we are in the chapter about functions, I should really write a function to do that for me instead of repeating several times the same formula. But this is for an upcoming video. All right, so compile this, run it. So ranmax is still good old ranmax, but this time I can generate random numbers that are going to be between 1 and 20, 1 and 20 included. Okay, so I've got a 4, 7, 18, and 16, no natural 20, no ones, no fumbles, so that's it. All right, so now that we have talked about scaling and shifting, let's play a little bit with this neat little program here. And those of you who have a high spot check, you probably already noticed something weird going on here. I'm going to run it again. Okay, run it again. So ranmax doesn't change. That's cool. That's normal. But my random numbers are 4, 7, 18, 16. And then the second time I run the program, the random numbers are 4, 7, 18, 16. And the third time, 4, 7, 18, 16. And the fourth time, 4, 7, 18, 16. So the RNG is the random number generator is playing tricks on us, or something is going on here. So what happens is that we don't have real random numbers in computing. Okay, generally what we have is an approximation called pseudo-random numbers. So there's an algorithm that is used to generate a sequence of number, and every time you call rand, you get the next number in the sequence. So if I kept calling rand more and more here, like for example, let's put this in a loop. Okay. For int I equals 0, I lesser than, let's do 20 of them, I plus plus, okay, and I'm going to do exactly that, printf of pretty much rolling a d20, and I'm going to go back here, I'm going to GCC this, and I'm going to run it. Okay, now we're talking about having a series of numbers that look like they are random relatively to one another. Okay, there's no mathematical progression here. Well, technically there's an algorithm generating that series. Okay, but for us it looks random. It's pseudo-random numbers generation. But the problem is that series, if I run it again, is always the same. You can pause the video, right, and double check. It's always the same series of numbers. So this is due to the fact that this algorithm that generates a large, like infinite series of pseudo-random numbers, and every time we call rand, we get the next one in the series. This algorithm generates this series in a deterministic manner. And it uses to do so something called a seed. A seed is just a long value, a long int value, right? And it uses it in its calculation to determine what the series of random number is going to be for this time. So when we run our code several times like that, what we get is we always get the default seed in the random number generator, and therefore we get the same sequence of randomness. That won't do in most of the time, right? So how can we change that? We have a nice little method called srand, also coming from stdlib.h. All of this comes from stdlib.h. So when I call srand, it's a way to seed the random number generator, to provide to the random number generator a parameter called the seed, a long int again, that's going to be used in its calculation to determine the sequence of random numbers that you're going to get every time you call rand. So what happens if I specify a seed like this, like so? 1, 2, 3, 4, 5, 6, 7, 8. So it's a long number, so long int, I can put something relatively long there. I'm going to compile the code, and I'm going to run it again. So I get 8, 10, 2, 18, 17. Let's just focus on the first one, right? First ones. And then if I run it again, I get the same thing, and the same thing, and the same thing. So I didn't fix my problem. Well, kinda. I got a different sequence, For example, if I was changing here some value, for example, instead of starting at 1, I would have a 9. Okay, save that. When I go here and I compile again and run it, well, I get a different sequence. But now it's going to be always the same sequence, right? I keep running the code and you get exactly the same sequence on the screen. That's the sequence of pseudo-random number that correspond to this particular seed value. So I can fix the seed value like this. I can hard code it in my code, or I could just ask the user, put s enter seed value. All right, and then scanf %L for long. I think that's %L. I'll have to double check in a second. %L for long. Read this in a long int my seed variable. There we go. Don't forget the ampersand. All right. And we are finally using this to call srand, and we pass to it the seed value that we just read from the user. All right. All right, so we could do things like that. Let me double check real quick. I think I had the page bookmarked here. In your textbook, you have a table that summarizes actually all of the format specifier for fprintf, scanf, etc. So I'm going to cheat as well and look it up real quick. Long int, yes, %ld, %ld. How could I forget that? %ld here for scanf. All right, so now I'm going to be able to seed differently my program every time it is executed. That's progress, right? So let's go for it. GCC, run it, enter a seed value. So 1, 2, 3, 4, 5, 6, and I get a sequence that starts with 24, 17, 19. Okay, let's run it again. 6, 5, 4, 3, 2, 1. So it started with 24, 17, and 19. Well, this is different. This is different. 17, 1, 4, and 20. Okay, so all right, I have a way every time I start my program to reinitialize a random number generator with a different seed value, and therefore cause my sequence of calls to the rand function to return a different sequence of return values. Very well. I don't want to have to ask the user to enter a seed. The user doesn't probably care about what a seed for a random number generator is, so we are going to try to be nice and spare them that. So there is a trick that is commonly used. Instead of seeding your random number generator based on a value that you type in the program or a value that the user gives you, we want something here that's going to change every time the program is run. Well, there is one thing that's going to change every time the program is run. It's the time. So there is a function called time in C that's going to take as parameter null. In our case, we're not going to use it in a very complex manner. So we'll talk more about the null constant, and we'll talk more about the time function in a few seconds, but the null constant in a few chapters, right? When we deal with pointers. The idea here is that we are just asking what is the current time. And the current time, actually, in a Linux or Unix system, it's represented by the number of milliseconds elapsed since January 1st, 1970. That's called the Unix epoch, or epoch for short. This is an arbitrary date that was selected as the beginning of time for Unix systems. And that number of milliseconds elapsed since January 1st, 1970 is also a long int number. So we can definitely fit that as parameter to the srand method. And the result of that is that if I run my program twice in a row very fast, even if there is only 1 millisecond of difference between the two executions, then that's going to be enough to generate completely different, well, not completely different seeds that are going to be off by 1, but again, 2 seeds valued that are following one another in the order of numbers is going to generate completely different series of pseudo-random numbers. So that's good enough for pseudo-random number generation. So where do we get time from? So if I try to save that, run this, gcc main.c, implicit declaration of function time. So you're getting used to those error message, right? Implicit declaration means I need to do pound include something to get the prototype for that function. Pound include what? That's the problem. Well, fear not, we have a manual page accessible right here, man time. So what happens this time? It gives me, no pun intended, sorry. It gives me the manual page for a command called time, and I know it's a command because it tells me it's coming from chapter 1 of the manual pages. So chapter 1 of the manual page is for command that I use at the Linux prompt, okay, as a bash prompt, the command line prompt. So that means that there is a command called time. And it's used actually to get timing information on how long it took to run a certain program. So for example, if I do time a.out, okay, it's going to run my program and then it's going to tell me, okay, the execution of your program took 0.007 seconds and as real time. Real time is the clock, wall clock time, okay? So on your watch, it took 0.007 seconds to execute this program this time. Out of those 0.007 seconds, thousands of seconds were spent actually in user land. What do we call user land? It's pretty much where everything that is non-kernel, non-operating system kernel executes. So all of your application, your desktop manager, all of those things are running in what we call collegially user land. Okay, this is a user space of your memory. And then there is actually the operating system running in kernel space, okay? And the operating system is in charge of executing system calls, okay? At the end of the day, all of your programs that are running on a computer, they call methods that come from library, they call methods that come from the operating system, sorry, they call function that comes from library, function that come from the operating system, and get the work done, their work done like this, okay? So it's either you call something that exists in user space or something that is implemented by your operating system, like generally these are low-level things, like, you know, what time is it? Can I access this driver? Can I access this hard drive, etc.? So these are like details that are not super relevant for us. I mean, they are interesting, but they are not necessarily relevant for the topic of this course. What's important is you can use a time command to time the execution of any arbitrary piece of program that you write. Awesome. But this is not what I was looking for. Okay, so when I do man time, by default, the manual page that I get is that of the command time. And there is a command time for the command line interpreter. But I want to use a time function inside my program. So from what we saw previously, the chapter 3 seemed to contain the manual pages for functions that I could use in the C language, like ceiling, round, rint, etc. But if I try to do man, the number of a section, and then the name that I'm looking for, so man 3 time, it tells me there's no manual entry for time in section 3. So what was section 3 exactly? Well, at this point, I need to know what the different sections are. Well, what do we do when we want information about something? We type man space and then a keyword, right? So if I want to have information about the manual system itself, I type man space man. All right, and it's going to tell me something about the option of that command, what it's supposed to do, blah, 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 blah. Oh, this is interesting. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the chapters, the section in the manual system, okay? So section 1 is executable programs or shell commands. For example, time from section 1 was a shell command. I could type it, run it on my command line interpreter. Section 2 is system calls. So remember I told you that everything that your program does is always based on calling functions that are either in user land or in kernel land, the operating system itself, right? And the operating system functions are called system calls, and they are generally dealing with low-level hardware-related stuff, like, for example, checking the time, accessing the network card, accessing any sort of peripheral, etc. So this is another source where I could find the functions that I use in my programs. And then the section 3 is library calls. Well, yes, when we are using functions from the math library, we found them in section 3. So let me try to look for time, but this time I'm going to look for time in section 2. Man, 2, time. Bingo. There we go. It tells me this is a time function. This is a data type it returns. This is pretty much a long int, okay? This is the parameters that it can take, and it explains everything. But what I'm interested in right now is this. Where do I find the prototype for that function? I find it in time.h. There we go. So this is how you use the manual page system to find out, the information that you didn't memorize or that you forgot. Like, for example, what is the header file that's going to allow me to use the time method, the time function. Now that I have this set up, gcc main.c, it's compiling a.out. So first one, 14.4.10.6. Second one, 20.14.4.19. Third one, 2.19.17.3. Okay, now I'm getting different results. Let me reduce a little bit the number of random numbers that we generate in the program. Compile again. I'm going to run it several times in a row as fast as I can. That's not really fast, but that's as fast as I can. There we go. We are getting, every time we run the program, different pseudo-random number sequences based on the exact time to the millisecond where we started executing the program. All right? So that's pretty much it. That's all there is to know for this course, at least on pseudo-random number generation and the rand method. It's going to come in handy every time we try to do things like simulating the roll of a die, or like any sort of game, etc., text-based game. So this is a useful command to know how to use. Don't forget about the shifting and scaling. And we are going to wrap it up for this video. Thank you again for your attention.